Welcome to Renewable System Integrator. Today we are going to discuss some of the basics of IoTs, that is Internet of Things. So this session already we had discussed 3 parts. If you missed out those things, you can refer the links in the description section so that you can try to know about the things that we have discussed in the part 1, 2 and 3. Now let's try to get into the part 4 of this session. What are the things that we are going to discuss today? How to optimize IP for IoT using the adaptation layer, and we are making a comparison between the IoT protocol stack utilization 6LoWPAN and the IP protocol stack IS made. Okay, and we are trying to discuss about the 6LoWPAN header frame format, compression, how compression is done, and how we can do the fragmentation for this header, and how the header mesh addressing looks like. Okay, and what are the protocol stacks for transporting the serial DNP SCADA over the IP. Okay, and what are the different high level protocols, what is scope, okay, and what is the message format of the scope looks like, and what are the fields of the scope field contains, what is MQTT, and what is the message format of this MQTT looks like, and what are the fields MQTT message field contains, and we are going to make a comparison between the scope and the MQTT. Okay, so optimization IP for the IoT using adaptation layer. If you see, the physical layer has the wired and the wireless, and for the data link layer we had included the IEEE 802.14.4G and IEEE 1802.15.4E. Okay, next is the adaptive layer. Next to the adaptive layer we have network IPv6 and IPv4, and for the transportation layer we can go for this TCP or UDP. Okay, when we make a comparison between the IP protocol stack and the IP protocol stack with the 6LoWPAN adaptation layer, you can see this in the normal IP protocol we have only physical, MAC, IP, TCP and HTTP. When you're going for this 6LoWPAN, okay, IP protocol stack with the 6LoWPAN, we are using the IEEE 802.15.4 as a physical and the MAC, and then we are using the LoWPAN. Next we are using the IPv6. So next to it we have a UDP option, and the final is we have the application protocols. Okay, and if you look into the header stack of this 6LoWPAN, okay, we can have 3 categories. One is 802.15.4 header, IPv6 header compression and the IPv6 payload. Then we are if you look into the fragmented header, we have a header compression and the payload, and if you get into the mesh addressing headers, then we can have a fragment header, IPv6 header and IPv6 payload. Okay, and when you make a header compression, okay, when you look into the frame, entire frame of this IEEE 802.15.4, okay, we can have a look into 2 different categories. One is without header compression and with header compression. When you see when the header got compressed, so many good things are happening, and we have a payload of around 108 bytes. Okay, but when you do without header compression, we have only payload of around 53 bytes. Okay, next how we can do the 6LoWPAN fragmentation header. The 4 important thing is that datagram offset is much important, then datagram tag, then size, then comes the 6LoWPAN fragmentation header. How we can do the 6LoWPAN header addressing header, that is FCS, destination address should be there, source address should be there, then we have a addressing header including the hot count. Next, if you want to transport a serial DNP3 SCADA over IP, okay, over the IP network we need the following things. One is that data link, physical, network and the transport. This is the common one. This is the basic IP layer. Next is the connection management is very much important. With the help of the IEEE 80.15.4 section we can use this. Okay, and when we see the DNP3 protocol, we have for the DNP3 also we have a data link layer, transportation layer and the application layer. And in the application layer, with the help of the logical communication from the master to the outstations, and the application fragmentation communication is happening. Okay, and if you get to the high level of IoT stacks for the OAP and MQTT, okay, so for IEEE 802.15.4 we have a physical layer, MAC layer and 6LoWPAN layer and IPv6 layer. Over it we have a UDP or TCP, and above all we have a OAP and MQTT. What is scope? It is nothing but constraint application protocol. Okay, it is a working group. It efforts to develop a generic framework for the resource-oriented application targeting the constrained nodes and the networks. Okay, it's primarily designed to facilitate the exchange of messages over UDP between the endpoints. Okay, including the secure transport protocol, that is datagram transport layer security. Okay, so when you look into the COIL message format, okay, in the message field we have a version, type, okay, token length, code, message ID, token, options and the payloads. So the version identifies a COIL version, and in the type it defines 4 messages, that is conformable, non-conformable, acknowledgement, reset. In this token length it can be 0 to 8 bytes. Code, this indicates the requisition method, okay, what format the message should be, in what format the response message should be. Those things will be decided in the code format. And the message ID is very much important, okay, because it helps to match between the acknowledgement and the reset between the messages. Next is a payload. It carries the the COIL application data, okay. And when you get into the COIL communication, the IoT infrastructure, okay, so the COIL plays important role in establishing the network or a communication between the NMS and the COIL. Okay, even with the HTTP COIL proxy also we can establish a communication. What is MQTT? It is nothing but the message queuing telemetry transport. Okay, so in even 1990s it's already discovered, okay, by IBM and the ARCOM team. Okay, because why we need this message broker, that is message queuing telemetry transport? Because in the client side we might have a temperature sensor, humidity sensor, pressure sensor, so many sensing devices might be there, even motion sensor will be there. Okay, but the application, our application should understand this is the temperature, because the sensor will only publish the temperature or its required output, but we need to subscribe to that and we need to know the information of those particular sensors. For that we need this message broker, that is MQTT server, that is message queuing telemetry transport. This protocol is a standardized one, okay. And when we get into the MQTT message format, okay, we have a connect, publish, pubak, pubruk, pubrel, pupom, subscribe, subak, unsubscribe, unsubak, pingrips, disconnect. So all these things we have in this MQTT message type protocol. Okay, and we have different values assigned for this message type, but we need to know the flow, how the flow is happening. Main important thing is that this connect is nothing but the request to connect. It happens between the flow happens between the client to the server, okay, in the MQTT message type. And when you go for a connect, it happens between the server to client. It is nothing but the acknowledgement, okay. And when you're going for a publish, it is nothing but the publishing the message. It happens between both client to the server as well as the server to the client. And publish acknowledgement, it happens between client to the server as well as from server to the client. Okay, once the publish is received, it also a flow which happens between the client to the server and the server to the client. And if you're going for a publish release, it also happens between the client to the server and the server to the client. Okay, when you're making a subscription request, it happens between the client to the server. When you're making a subscription acknowledgement, it happens between the server to the client. When you unsubscribe, it happens between the client to the server. When you unsubscribe acknowledgement, it happens between the server to the client. When you make any ping request, it happens between the client to the server. When you get a ping response, it happens between the server to client. Okay, and when you're making any disconnection, it happens between the client to the server. So this is a most important broker which connects different protocols, because nowadays whatever technology, even for the YouTubes, we are using this MQTT message type technology. And if you make a comparison between the COIL and the MQTT, the main transport protocol for the COIL is UDP, whereas MQTT is transmission control protocol. The typical messaging format of COAP will be request and the response. And when you go for MQTT, it will be publish and subscribe. Okay, and the effectiveness, if you see, for between the COAP and the MQTT is COAP is excellent, whereas MQTT is pretty fair. Okay, so it has a DTL security, whereas it has SSL security. Okay, and this communication model of COAP is one-to-one communication. When you go for MQTT, it is a many-to-many communication. Okay, and we need to get into the strength and weaknesses of this COAP and the MQTT. For the COAP, it is a lightweight and fast. It has a low overhead. It is suitable for networks. Okay, and it is supported by multicasting. Okay, and also asynchronous and synchronous messages we can do with the help of this COAP. Whereas in case of MQTT, it is a TCP and multiple QoS option. It provides robust communication, simple management, and scalability using a broker architecture. When you get into the weakness, okay, it is not as reliable as TCP based MQTT. So the application must ensure reliability. Reliability is one of the weaknesses of this COAP. When you get into the MQTT, it is a high overhead for constrained devices and the network. Okay, and the TCP connection can drain low power devices. No multicasting support. That is a disadvantage of this MQTT. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had provided the contact details here. We are providing design, installation, testing and commissioning, consultancy, training supports for solar, on-grid, off-grid and hybrid application. And if you want to have a plan to work in abroad, if you want to know, want to have a basic training in the home automation and the building automation, you can contact us. We had provided the contact details here. We are also providing design, consultancy and training support for the home automation. And if you want to know the basics of this IoTs, so we are providing training on the IoT also. You can contact us. We have provided the contact details here. Thank you so much. And this part is not yet over. We had as we the starting of the section of we got told we have 6 parts. If you missed out any of the part, in the description we are providing the link. So by referring that link, you can try to know about the different things which is discussed in this IoT. Thank you so much.